This is the Wiiboox Luckybot. It's a food extruder that's designed to be a drop-in replacement on Creality Ender 3 style printers. It hasn't been launched yet, and Wiiboox is working on a Kickstarter campaign for it, and they sent me one of these extruders to review. I've had a little bit of experience with paste extruders in the past, having built one, and so I was excited to give it a try. The video you're seeing here is one of the only successful prints I was able to get off of this extruder. Just getting the Luckybot to this point was an absolute ordeal, and in this video we're going to talk about some of the factors that make drop-in hardware replacements like this, especially Kickstarter campaigns, so difficult for manufacturers to do correctly. This video has a little bit of everything: hardware issues, software issues, firmware issues. There's even a fire hazard involved too. So if you just want to see the Luckybot printing, go ahead and skip to the printing section of this video. Otherwise, stick around and we're going to go through the entire process of getting this thing installed, starting with the hardware, then we're going to talk about the software, and then we're going to talk about the actual extruder itself. This isn't really a review video, so if you're thinking about buying one of these, the only reason you should watch this video is because it's a little bit of a cautionary tale. So let's start by unboxing the Luckybot. I had high expectations for the Luckybot as soon as I saw the package. It's well designed, there's an instruction manual and foam cutouts for all the parts, and it just looked really professional. The user manual looks okay at first glance. It shows some disassembly instructions, and we're going to talk about those in a little bit. But at first glance, it looked pretty good. I didn't really see any giant red flags, nothing really jumped out at me. The accessory box includes a couple of cables as well as a mounting bracket that you use to install the Luckybot onto your printer. One of the cables is a Z-axis end stop extension, and the other one is for plugging the extruder into the printer. The syringe that it comes with it looks like a medical syringe. It looks like somebody cut the back off of it, and my first thought was, man, this is going to be hard to replace. Looking at the actual extruder itself, it's really well built. It looks super sharp, it's got stickers on it, it looks like a well-engineered piece of equipment. And again, I had really high hopes when I got to this stage. The first thing I noticed during the setup process is the instructions actually call for you not to remove the circuit part of the original nozzle. So I think what they're talking about is the wiring, and this is a shockingly short-sighted approach to removing an extruder. This means that you have a hot nozzle, hot enough to ignite paper, sitting right next to the printer for the duration of the print. This isn't just a bad idea, it's a straight up fire hazard, and it even says in the instructions, watch out, it's going to heat up during printing. So I don't know what the engineers at Wiiboox are thinking, but this is totally not okay for an add-on product for a 3D printer. Despite this huge red flag right from the get-go, I still wanted to try out the Luckybot on my printer, so I removed the entire hot end assembly. This includes the heater cartridge, the thermistor, all the wiring, and the heat shrink tubing. This is definitely the safest way to move forward, but it is going to take me hours and hours of work to get to the next stage in this process. You can see down here I've already undone the wires for the heater block, and I have left the thermistor plugged in. We'll take a look at that in a second. The extruder for the printer I've unplugged, and the thermistor itself I've actually coiled up and put under the printer. This way the printer is constantly showing that it's room temperature. If you unplug that, it'll throw a temperature flag error and the printer won't really react reliably. So here we have a consistent temperature being measured. So let's talk about the Luckybot cartridge itself. You'll notice it's got 3 brass inserts. So when you first see it, you think, okay, great, it's gonna have 3 points of contact. But when you actually mount the bracket, you'll see that there's 2 points that mount it to the gantry on the 3D printer, but the third hole doesn't actually line up. You can see if I tilt it to the side, I can see straight through it, but it's actually just a little bit off, which is a pretty huge QC issue. And you can see on the bottom, the 2 bolts screw right in, no problem, but the one on top doesn't mount, and in the instructions, it actually only shows the bottom 2 being installed, which indicates Wiiboox knew that this was an issue. So if you're wondering why this is a big deal, well, this is a big, heavy accessory, and it's not really locked into place, so it's not constrained, it can still sort of wobble back and forth. The door of the extruder is held in place with 4 little magnets and pogo pins. I hate pogo pins. I have no real rational reason for disliking them, but they're so delicate, and when you have them on an accessory that's going to vibrate back and forth, especially something that's going to be opened, there's a legitimate concern they're not going to keep good contact. Okay, so just to recap, we've removed the bracket with both cooling fans attached to it, the hot end, the nozzle, the heater block, the heat shrink tubing, and all of the associated wiring. So this is everything that we've pulled off, and we've replaced it with the Luckybot extruder. Next, we have to set the steps per millimeter for the new extruder. The instructions call for 750 steps per millimeter, but when I went to go update it on the printer, it was firmware locked at 186. Not the end of the world, I just fired up a terminal in Cura and actually sent the command to update it to 750 manually, and that actually worked. Once that was sent, I could go into the menu and see that it was persistent. So even after restarting the printer, it would stay at 750. So now that the hardware is all installed, we should be able to start printing, right? Nope, not even close, not by a long shot. The next part of this process took me almost as long as setting up the hardware. This was probably about 10 hours combined between solving hardware and software bugs. Right off the bat, the printer recognizes that the heater block is missing, and it'll prevent any signal from being sent to the extruder while the nozzle's technically cold. So in order to fix this, we actually have to go into Marlin and update the firmware to get rid of the prevent cold extrusion line. This was a massive pain, and I think it's way past what's reasonable to expect somebody who's bought this extruder to go through. I think most people who are buying the Luckybot expect to just slap it on and start printing, not spend an hour and a half mucking around in Visual Studio trying to get an updated firmware. On top of everything else, flashing the firmware is a complicated process. It involves disassembling the printer and doing things that might be difficult to undo later. So one of the only consolation prizes that I got out of this entire experience was after reflashing the firmware, I discovered it's actually possible to change the boot screen on your printer. So that was kind of cool. And now I have this. So now the hardware and the software are set up, so we should be good to go, right? Nope, guess again. The hardest part is actually still ahead of us. We have to build a profile in a slicer app for printing chocolate. I reached out to Wiiboox and asked them if they had a profile I could use, and they sent me this video. You ready? Did you catch all that? Here, let's watch it one more time. That's not sped up or anything, that's just how fast the video is. On top of not really having a lot of detail, when I pressed Wiiboox for more information, they said, oh, you can just import an STL and hit print. So I knew this was going to be a struggle. I knew that creating a profile was going to be a challenge. I've built a paste extruder before, and I know that it's a difficult process. So I tried to build everything in Prusa Slicer. It's just what I'm used to, and it's what I have a little bit of experience with. The last paste extruder I built used Prusa Slicer, so I figured I'd give it a shot. If you are watching this video hoping to find a profile for your Luckybot, I don't know what to tell you. Hopefully by the time that you're watching this, Luckybot has released a universal profile for Cura or Prusa Slicer, but in the meantime, it took a lot of fiddling and I'm still not super happy with where I got. Okay, so now we have hardware, software, and slicer profile ready. Now can we try printing something? Yes, now it's time to try printing something. First, we have to fill the cartridge, and the instructions are so simplified, they're almost offensive. It says, after the chocolate's completely melted, fix the tube, pour the chocolate slowly, and it's got a picture of chocolate being poured from a pitcher. You don't need to be a chocolatier to know this is not how chocolate works. So I bought some easy melt chocolate. I figured that would be the best chance of success I had at actually filling this tube. So I put a couple of chunks in a microwave safe container and microwaved them for about 2.5 minutes until it was runny enough to pour. You have to be really careful when you're pouring the chocolate to try and avoid air bubbles. Air bubbles won't rise up out of the chocolate, and during extrusion, they'll come out as pops and they'll give you all these wacky, inconsistent extrusions. Once the chocolate tube has been fully filled, we're going to put the rubber plunger in there and try and get it to sit flush. Because it's a rubber plunger, it introduces compression into the system, which is incredibly annoying, and also it doesn't really want to go flat. It always kind of rocks to one side or the other, so it's going to make a mess. There's really no way around it. Once the tube's been filled with chocolate, we want to refrigerate it so it solidifies and we can avoid getting any air bubbles in there. Once I've pulled it out of the refrigerator, I let it come to room temperature before sticking it into the cartridge and hitting preheat. The preheat brings it up to 34 degrees Celsius, that's the target temperature, and it does this over time. We'll let it sit for about a half hour before actually hitting extrude. So after all of our hard work, it's almost time to see our first bead of chocolate extruded. So let's go ahead and try it. Huh, okay. Maybe we should just try it one more time. So what's happening here? The chocolate has been liquefied, and if I pull the tube out and squeeze it, I can remove it manually, but for some reason I can't get it to extrude. I verified that the nozzle isn't clogged, and I've even tried bringing it up to 45 degrees C for a half hour to see if that helped. So, did it? I can see that the chocolate is melted, and pushing on the tube causes it to extrude from the nozzle, so I know that the nozzle isn't clogged either, but the motor doesn't seem to have enough torque to actually push the chocolate through. I even tried removing the majority of the chocolate from the tube to see if it would make a difference, and it didn't. On top of everything else, I disassembled the lead screw mechanism to see if there's any blockage, and I found the top of the lead screw was covered in metal shavings. Metal shavings right near the chocolate. I thought a lower viscosity material like peanut butter might work, but still nothing. Holding down the extrude button would cause some material to come out, but you can see it rapidly start to under extrude. This can be fixed by holding down the extrude button again, but still, it's only a temporary fix. Eventually, the amount of force required to push the material, it's just too much for the motor. I tried the lowest viscosity material I could think of that would still hold its form and not just fall out of the tube, and that was cake icing. And this actually worked. This was the closest thing to a successful print that I got, was with cake icing. I'm not going to say don't buy the Luckybot, but I can definitely say you should not buy the Luckybot if you think that it's going to be a plug-and-play operation. This was a massive time sink, and I spent way more time than I should have, and if you can't tell, I might be a little bit salty about that. If you're interested in 3D printing chocolate, I would highly recommend taking a minute to read about the Cocoa Press by Evan Weinstein. Evan has put a tremendous amount of time and effort into making a 3D printer capable of printing chocolate, and he actually helped me quite a bit while making this video. My experience with the Luckybot was a disappointing one, and I think Wiiboox really has their work cut out for them if they're going to make this product successful. On top of not being totally functional, it's actually outright dangerous to have the Luckybot set up as it stands right now. The Luckybot is not a plug-and-play solution. Don't get me wrong, it's a gorgeous piece of hardware. The injection molded enclosure looks great, it has a bright backlit screen and backlit buttons, and it looks really nice, but it's just not functional to the level I would expect. All that being said, I think there is a market for a plug-and-play food extruder, I just don't know if this is the one. I would love to hear your thoughts. Please leave me a comment and let me know what you think of the Wiiboox. Do you plan on pre-ordering one? If so, what do you plan on making with it? As always, thanks for watching and have fun printing.